Hello students and good morning to you all. So today I am doing class for class 12 science, and in the last online class we did theorem on, that is we did Rolle's theorem and Lagrange's mean value theorem. So in that online class we did only the theory portion. So today we'll do problems on Rolle's theorem. So how will you do problems on Rolle's theorem? And in order to do problems on Rolle's theorem, you should know the statement of Rolle's theorem. You know that, isn't it? So what is the statement in Rolle's theorem? Suppose y is equal to f of x be a real valued function defined in the closed interval a less than or equal to x less than or equal to b, such that number one, f of x is continuous in the closed interval a less than or equal to x less than or equal to b. Number two, f of x is differentiable in the open interval a less than x less than b. Number three, f of a is equal to f of b. Then there exists at least one value of x, say x is equal to c lying between a and b, such that f dash of c is equal to 0. Okay, so there exists at least one value of x, say x is equal to c lying between a and b, such that f dash of c is equal to 0. तो यो जुन चाहिँ c को भ्यालु छ, यो c को भ्यालु चाहिँ a र b को भित्र हुनु पर्यो. Within a and b this c should lie. Okay, so f dash of c is equal to 0 भनेको के हो? मैले लास्ट अनलाइन क्लासमा तिमीलाई बुझाएको थिए. That is the tangent at any point c on the curve is parallel to the x-axis. So in this case, f dash of c is equal to 0 भनेको slope of the tangent at the point c is equal to 0. It means that the tangent at the point c on the curve is parallel to the x-axis. Clear? So now we will use this statement in order to do this problem. त तिमीले के याद गर्नुपर्छ? Algebraic expression in x or polynomial in terms of x. That is, this x square plus 2x minus 8 is an algebraic function in terms of x, or this is also known as polynomial of degree 2. That is polynomial of degree n. That is your this function, polynomial function of degree n. Then comes logarithmic function, trigonometric function, exponential functions, and inverse circular function are all continuous and differentiable function in its domain. Okay, so domain means those values of x for which the function f of x is defined. Those real values of x for which the function f of x is defined is known as the domain of the function f of x. Okay, so you should remember that, you should understand that the polynomial of degree n or algebraic terms, algebraic expression in terms of x, logarithmic function, exponential function, trigonometric function, and inverse circular function, all these functions are continuous and differentiable in its domain. Okay, so now since this is an algebraic expression, that is, this is polynomial of degree 2, and this polynomial of degree 2, this expression is continuous, this function of x is continuous and differentiable in the given interval. Okay, that is minus 4 less than or equal to x less than or equal to 2. So first of all you have to write here, since this is so you can write all the polynomial function of degree n of degree n are continuous and differentiable in its domain. Right? That is not only all polynomial function, but it may be logarithmic function, exponential function, trigonometric function, and inverse circular function. So all these functions are continuous and differentiable in its domain. Okay, Now polynomial function of degree n are also continuous and differentiable in its domain. So therefore the function f of x is continuous. The function f of x is continuous in the closed interval. The closed interval you can write it within third bracket, okay, -4, 2. So this is another way of writing this interval, right? This means that -4 less than or equal to x less than or equal to 2, or you may write this one also here, or you may write it within third bracket -4, 2, that is x lies within -4 and 2. And also the function f of x is differentiable in the open interval, that is, so open interval can be written like this within first bracket -4, 2. And now we have to find out f of a is equal to f of b. Here a is -4 and b is 2, right? So what is f of x out here? So f of x is equal to x square plus 2x minus 8, right? So what is f of -4 now? So let us find out f of -4. So instead of x you put -4. So it is -4 whole square plus 2 into -4. Then write down -8, right? So let us simplify it. -4 whole square is 16 minus 8 which is equal to 0. Again you find out f of 2. What is the value for f of 2 now? Instead of x you can write 2 here. So it is 2 whole square plus 2 into 2, right? So 2 whole square plus 2 into 2 minus 8. So which is equal to, this is 4, 2 to the 4 minus 8, which is equal to 8 minus 8 is equal to 0. Therefore in this case we have f of -4 is equal to f of 2. Is that clear? त यसलाई हामीले डिफरेन्शिएट पनि गर्दा हुन्थ्यो. Since f of x is equal to x square plus 2x minus 8. So what is this differentiation? You can differentiate it. What is f dash of x? Because you know the differentiation, we have already finished first order derivative, isn't it? So what is f dash of x now here? What is the differentiation of x square? It is 2x. What is the differentiation of 2x? Plus 2, and for minus 8 it is 0. Okay, so what is f dash of x here? It is 2x plus 2, right? So now all the conditions of Rolle's theorem are satisfied here, or satisfied, isn't it? All the conditions of Rolle's theorem, that is 3 conditions are there. One is f of x is continuous in the given closed interval, f of x is differentiable in the given open interval, and f of a is equal to f of b. So in this case all the conditions of Rolle's theorem are satisfied. So what can you write now? So write down here, therefore all the conditions of Rolle's theorem are satisfied. So therefore there exists at least one value of x, say x is equal to c, lying between a and b. Here what is a and b? Here a and b is -4 and 2. Lying between, here a is -4 and b is 2, such that f dash of c is equal to 0. Okay, such that f dash of c is equal to 0, right? Now you have to get the value for f dash of c. We have already got f dash of x is equal to 2x plus 2. Now what is f dash of c? Instead of x you put c, so it is 2c plus 2, isn't it? So or it is 2c plus 2 is equal to 0. Let us get the value for c. 2c is equal to -2, or c is equal to, this is your -1. That means this -1, you know that this -1 lies in between -4 and 2, isn't it? That is Therefore minus 4 less than minus 1 less than 2. That is, there exists at least one value of x. Say x is equal to c lying between minus 4 and 2. That is, in this case, what is the value for c? C is equal to minus 1. And you know that this minus 1 lies within minus 4 and 2. So therefore Rolle's theorem is verified. So we can write down hence Rolle's theorem is verified. Hence Rolle's theorem is verified. So this is the method for doing the problem of Rolle's theorem. Okay, so we can copy it. Now we'll do the next question. Now we'll do the next question, that is question number 2 of number 2. So you have to verify the truth of Rolle's theorem for the following function, that is f of x is equal to x cube plus 5x square minus 6x in the closed interval 0 less than or equal to x less than or equal to 1. So this is also the polynomial function of degree 3. As you know that the polynomial function of any degree is continuous and differentiable in its domain. Okay, so here the function f of x is continuous in the closed interval 0 less than or equal to x less than or equal to 1. Okay, so let us first differentiate it. हामी differentiation गरिहालौं पहिला, किनभने हामीले c को भ्यालु निकाल्नु छ, यसमा differentiation गर्नै पर्छ, so that f dash of c is equal to 0. Okay, so let us differentiate it. Differentiating both the sides with respect to x. So this is the solution. So now what is f dash of x is equal to, this is your 3x square plus 10x minus 6. Okay, now write down the three conditions. Whether these three conditions are satisfied or not, you have to check it. So this function of x is the polynomial function of degree 3, so it is continuous in the given closed interval. The function f of x is continuous in the interval, in the closed interval, that is 0 less than or equal to x less than or equal to 1, or you may write within third bracket 0 comma 1. Is that clear? So again, this function of x is differentiable in the open interval 0 less than x less than 1. The function f of x is differentiable in the open interval 0 less than x less than 1, or you may write within first bracket 0 comma 1. This is your notation of open interval. Okay, now you have to check for f of a is equal to f of b. Here a is 0 and b is 1, right? So here given function f of x is equal to x cube plus 5x square minus 6x. Now let us find out f of 0 first. So f of 0 is equal to 0 cube plus 5 into 0 whole square minus 6 into 0. If you simplify it, you will get 0. Next, just find out f of 1, which is equal to 1 cube plus 5 into 1 whole square minus 6 into 1, which is also 0. That is, f of 0 is equal to f of 1. So f of 0 is equal to f of 1. So these three are the conditions of Rolle's theorem. So all the three conditions are satisfied here. So you have to write, so all conditions of Rolle's theorem are satisfied. All conditions of Rolle's theorem, all conditions of Rolle's theorem are satisfied. All conditions of Rolle's theorem are satisfied. Therefore, there exist at least there exists at least one value of x, x is equal to c, lying between a and b. What is a and b out here? 0 and 1. Between 0 and 1, such that f dash of c is equal to 0. Is that clear to all of you? Now what is f dash of c here? So instead of x, if you put c, it becomes 3c square plus 10c minus 6. Therefore this will be 3c square plus 10c minus 6, which is equal to 0. So I think you have understood it. Okay, so what is, since f dash of x is equal to 3x square plus 10x minus 6, you have to get the value for f dash of c. So instead of x, you put c, you will get 3c square plus 10c minus 6, which is equal to 0, right? So now can you factorize it? No, we cannot factorize it. Okay, so you can use Sridhar-Acharyya's formula. You know Sridhar-Acharyya's formula, isn't it? You have to get the value for c. C is equal to, what is Sridhar-Acharyya's formula here? Minus b plus minus root over b square minus 4ac, this whole divided by 2a, right? So let us put the values now. Therefore c is equal to what is a here? A is 3, b is 10, and c is minus 6. So minus 10, then plus minus root over, what is b square? B square is 10 whole square, right? B square is 10 whole square minus 4ac, minus 4 into what is a भनेको 3 छ यहाँ, अनि c भनेको त्यो minus 6. Minus 6, this whole divided by 2 into a. What is 2 into a? 2 into 3, right? Or c is equal to minus 10 plus minus within square root. 10 whole square is 100. Minus minus plus 4 3s are 12, 12 6 are 72, divided by 2 3s are 6, or c is equal to minus 10 plus minus root over, this is your 172 divided by 6. So now we have to simplify it. So root over 172, how can you find out the square root of 172? So I think you have understood it. You have understood the simplification, I think. So let us find out the square root of 172. 172, right? So what is the pair of 2? It is 7. You have to take the terms in pair. The pair of 2 is 7. So this is only 1. So it doesn't have, this 1 doesn't have a pair. So 1 remains as it is. Okay. So now let us find out the square root. You know how to get the square root, isn't it? So let us get the square root of 172. You cannot get the exact square root of 172. So you have to write it in terms of decimal. Okay. So 1 1s are 1 cross 72. Add 1 in this case. 1 plus 1 is 2. Then what will you write? 3 times, right? 3. So it is 3 3s are. If you write 3 here, you should write 3 here also. Same number should be there. So you can't write 4 4 here, because 24 multiplied by 4 is 96, which is more than 72. And this 96 cannot be subtracted from 72. Okay. So it should be less than 72. So 3 3. 3 3s are 9. 3 2s are 6. This is 3. Now you can put decimal point here. You can write decimal point there. If you write decimal point here, you have to write 2 zeros out here. So here you can add, this 3 is written out here. So you add 3 here. This is 26. Now 1 1 1. So this is your 261, right? You can't put 2 here, because 262 into 2 will be more than 300, right? So subtract it. What do we get? 9 3 39, right? So now again, since we have taken a decimal point, you can put double zeros out here. You have to put, in case of the square root, you have to put double zeros, right? So here you can add 1 here. So this is 262. So how much time it goes? Again it is 1 1. Okay, that is 2 6 2 1. So approximately it is 13.11. So right here, or C is equal to minus 10 plus minus, what is the square root of 172? It is 13.11 whole divided by 6. So in this case, this C should lie between 0 and 1. 0 and 1 means positive. So you can't take negative sign here. So you have to take the positive sign in this case. If you take negative sign, this value will be negative, and C does not lie between 0 and 1. But C should be positive in this case. So write down taking only positive sign. So write down taking only positive sign. You can't take negative sign here. Taking only positive sign. So what do we get? Therefore C is equal to minus 10, write only plus sign, 13.11 divided by 6, or C is equal, now we can subtract it. 13.11 minus 10, how will you subtract it? You know how to subtract it, isn't it? 13.11 should be 10 should be subtracted from 13.11, right? Minus. So it is 3.11. So it is 3.11 divided by 6. Is that clear to all of you? Now divide 3.11 by 6. How much is it? You can write 3, 0. 6 le 3 la divide hunda, so it is 0. So this is 31. 6 5s are 31. You can take 1 here, 1 time. 6 1s are 6. This is your 50. 6 8s are 48. So approximately, if you want to write after decimal point only 2 figures, then यो point को पछाडि तिमीले दुईटा फिगर लेख्छौ भने त्यो 1 को पछाडि 8 छ. Since this number is 5 or more than 5, if this number is 5 or more than 5, then you can add 1 to the previous number. But if this number after 1 is 4 or less than 4, you don't have to add 1 to the previous number. It becomes 0.51 only if the number after 1 is 4 or less than 4. But if the number after this 1 is 5 or more than 5, then you can add 1 to the previous number. But in this case it is 8, so it is more than 5, so you can add 1 to the previous number. So its approximate value is 0.52. So its approximate value is 0.52. Is that clear? That is, this 0.52, this value of C lies between 0 and 1. So therefore 0 less than 0.52 less than 1. So therefore Rolle's theorem is verified. So in this case also Rolle's theorem is verified. So here Rolle's theorem is verified. So I think you have understood it. So this is the method. So this is the method of doing the problems on Rolle's theorem. Okay. So we'll do the next problem now. Now we'll do the next question, that is number 3 of question number 2. You have to verify the the truth of Rolle's theorem for this following function. So f of x is equal to x minus 1 into x minus 2 into x minus 3 in the closed interval. So this is the sign of closed interval, that is 1 less than or equal to x less than or equal to 3. Okay. So you have to verify Rolle's theorem for this function in the closed interval 1 less than or equal to x less than or equal to 3. So if you multiply it, you will get the polynomial function of degree 3. And you know that the polynomial function of degree 3 is continuous and differentiable in its domain. Okay. So here let us differentiate it first. Okay. So differentiating both the sides with respect to x. So therefore f dash of x, you can use the product rule out here, UVW rule, you know that, isn't it? So now let us first differentiate the first expression. What is the differentiation of x minus 1? It is 1 minus 0. So these two factors remain same. X minus 2 into x minus 3 plus. Next, now let us differentiate this second function x minus 2, keeping x minus 2 and x minus 3 as they are, right? So it will be x minus 1 into x minus 3 into, what is the differentiation of x minus 2? That is also 1 minus 0, which is equal to 1. Plus, again, take the differentiation of x minus 3, which is also 1, keeping these two factors as they are, that is x minus 1 into x minus 2. Is that clear? And the differentiation of x minus 3, as you know, that is 1. So this is the product rule. Okay. So, or now f dash of x is equal to, now let us simplify it here. X into x is x square minus 3x minus 2x plus 6 plus this one is x square minus 4x plus 3. You know that minus 3x minus 6 is minus 4x. Then it is x square minus 3x minus 2 minus plus, this is 2, right? Or what is f dash of x now? Which is equal to x square plus x square plus x square. That is your 3x square. This is your minus 5x minus 4x minus 9x minus 12x. It is minus 12x, then 3 plus 2, 5 plus 6, that is your 11. That is 3x square minus 12x plus 11. That is your differentiation, right? So here you can write, therefore the function f of x is continuous in the closed interval. How can you write down the closed interval? Within third bracket it is 1 comma 3. Again the function f of x is differentiable in the open interval, that is within first bracket. Open interval is written within first bracket, that is within first bracket 1 comma 3. And you have to show that f of a is equal to f of b. That is f of 1 should be equal to f of 3. Here a is 1 and b is 3. So now what is f of x here? F of x is equal to x minus 1 into x minus 2 into x minus 3. So if you put f of 1, so because of this x minus 1, 1 minus 1 will be 0, 0 into any number will be 0. And what's about f of 3? Because of this x minus 3, 3 minus 3 will be 0, 0 into any number is always 0, that is f of 1 is equal to f of 3. Therefore, f of 1 is equal to f of 3. So in this case, all these three conditions of Rolle's theorem is satisfied. So you have to write, so therefore all conditions of Rolle's theorem, is satisfied. All conditions of Rolle's theorem is satisfied. So what can write? Therefore there exists at least one value of x, say x is equal to c, lying between 1 and 3, lying between 1 and 3, such that f dash of c is equal to 0. Is that clear to all of you? So now what is f dash of c? F dash of c is this one, right? Therefore 3c square minus 12c plus 11 is equal to 0. And from here you have to get the value for c. Okay. So here also you cannot factorize it. Use Sridhar-Acharyya's formula here also. Okay. So here also let us use Sridhar-Acharyya's formula. So compare it with the quadratic equation ax square plus bx plus c. So here a is 3, b is minus 12 and c is 11, right? So what is Sridhar-Acharyya's formula now? C is equal to minus b plus minus root over b square minus 4ac this whole divided by 2a. So therefore c is equal to, what is minus b? Minus sign is already here, write down minus. What is b here? Minus 12. So it is plus minus root over, what is b whole square? Minus 12 whole square minus 4 into, what is a? 3 into 11, right? Whole divided by twice a, it is 2 into 3. Is that clear to all of you? So now you have to simplify it further now. Or c is equal to, this is your 12 plus minus root over, it is 144 minus 4 3s are 12 into 11, 132 divided by 3 2s are 6. Therefore c is equal to 12 plus minus within square root, 4 minus 2 is 2, 4 minus 2 is 1, whole divided by 6. So let us get the square root of 12, right? So let us get the square root of 12. So you rough part ma, rough work ma तिमीले square root of 12 निकाल्नु पर्छ. तो 2 को जोडी नै 1 भयो. कुन चाहिँ त्यस्तै नम्बर मल्टिप्लाई गर्दा 12 भन्दा कम्ती हुन्छ. 3 3 is 9, 4 4 is 16. That is 3 3 is 9. This is 3 3 is 9. 12 minus 9 is 3. Point there हामी कतिवटा जिरो झार्छौं स्क्वायर रुटमा, स्क्वायर रुट निकाल्दा फेरि डबल जिरो झार्छौं. अब यो 3 मा हामी 3 एड गर्छौं. 6 2 ले जान्छ कति ले जान्छ 3 4 5 5 ले जाँदैन 4 ले जान्छ. So 4 4s are 16, 6 1 6 4s are 24 plus 1 is 25, isn't it? Now subtract it, 44. Again you can put double zero out here, so you can add here 4, it is 68. So now कुन चाहिँ त्यस्तै नम्बर लेख्दा फेरि यो 4400 भन्दा कम्ती हुन्छ. 7 8. Is it 7? Not 7, 6 I think. It goes 6 times, right? If you write 7 times 7 7, 6 8 7 7, 7 7s are 49, 4 8 7s are 56 plus 4 is 60, isn't it? 7 7s are 49, 4 8 7s are 66 plus 4 is 70, 7 6 are 42 plus 7 is 49, isn't it? It is more than 4400, right? It is 7 7s are 49, 9 4 7 8s are 56 plus 4 is 66, 7 6 are 42 plus 6 48. So it is more than 4400. So you should write here 6 6 are 36, 3 8 6 are 48 plus 3 is 51 1 5, 6 6 are 36 plus 5 is 41. So approximately it is 3.46. So therefore c is equal to 12 plus minus 3.46 whole divided by, that is your 6. So you can take both the sign here because both are positive in this case. So if you take positive sign, it will be, if you take plus sign, it will be what? 12 plus 3, 15.46 divided by 6. And what is the other one? If you subtract it, 12 minus 3.46. It is 12 minus 3.46. 12 minus 3.46. So point को पछाडि हामी डबल जिरो लिन्छौं. 4 5 11 8 8.54. So 8.54 divided by 6. So approximately you can divide it, right? So this is 6 2s are 12, 34. It is 6 5s are 30, 46. That means 6 7s are. Approximately it is 2.57. And what is the other one here? It is 6 1s are 6.25. 6 4s are 24, 14. It is 6 2s are 12. So approximately it is c is equal to 2.57 and 1.42. So both these point, that is both these values of c lies within 1 and 3. So you can write here, therefore 1 less than 2.57 less than 3, and you can write 1 less than 1.42 less than 3. So both these values lie within 1 and 3. So the Rolle's theorem is verified here. So you have to write here, therefore Rolle's theorem is verified. Therefore Rolle's theorem is verified. So this is the answer. So I think you have understood it. त तिमीले यो क्वेशन नम्बर 4 चाहिँ होमवर्क गर्ने ल. So question number 4 is same question number 2 and question number 4 here is your homework. So question number 4 is your homework. That is the question is, it is same as problem number 1 to 3. So f of x is equal to x cube minus x square minus 4x plus 4, right? F of x is equal to x cube minus x square minus 4x plus 4 in the closed interval minus 2 less than or equal to x less than or equal to 2. So this is your homework, right? So as I am looking at Rolle's theorem for polynomial function of degree 2, degree 3, degree 1 मात्रै गर्यौं. Degree 2 र degree 3 को मात्रै गर्यौं हामीले. ठीक छ? So this much is for today. So you can revise all the problems that we did today at home. The next online class मा चाहिँ हामी अरु trigonometric function, exponential function को हामी Rolle's theorem गर्छौं. Whether the Rolle's theorem is satisfied for exponential function, for trigonometric function, for inverse circular function and so on. Okay? So we will do that problem in the next online class. So this much is for today.